Welcome to day 3 of the Machine Learning Teach by Doing project. My name is Dr. Raj Dandekar. On day 1, we looked at why we started this Machine Learning Teach by Doing project. And on day 2, we started by looking at the introduction to machine learning, introduction to artificial intelligence. We also saw the differences which exists between AI, ML, and DL, that is artificial intelligence, machine learning, and deep learning. We saw that AI is the broader umbrella, ML is the subset of AI, and DL is the further subset of ML. We also looked at the history of ML, and we saw that we live in times right now where the availability of computational power, along with access to data and development of innovative algorithms, has really accelerated uh, the innovations in the AI space. And that's why AI is affecting every single aspect of our lives. We are really lucky to be living in this age right now. In today's lecture, or in day 3 of the Machine Learning Teach by Doing project, we'll be looking at the types of ML models. As is the case throughout this Machine Learning Teach by Doing course or project, I'll be taking references from two resources. The first is MIT's 6.036 Introduction to Machine Learning course, and the second is Microsoft's ML for Beginners course. So if you have not seen the previous two lectures, I really recommend you to go through them so that you understand why we have chosen these as a reference material. As I mentioned, today we'll be looking at the types of ML models, and the reference which I have predominantly followed for this is the MIT's course, especially this video on supervised learning. These lecture notes where this instructor goes in a lot of detail about the different types of ML models, and other videos also associated with the types of ML models which come under the introduction to ML section of this course. So if you go to the course content, you will see that there is week 1 basics and there is introduction to ML. So I'm still in this particular section and I've covered the videos associated with supervised learning. The Microsoft course does not have too much detailed information on the types of ML models, and so I have decided to cover this from the MIT's course, which is pretty deep in theory. Okay, so let's get started with looking at the types of ML models. The first type of machine learning model, which is really very important and it has a huge range of applications, is called as supervised learning. In supervised learning, we are essentially given a data set like below, where X represent the input and Y represent the output. So let's say we have n input output pairs. The main idea of supervised learning is to learn the relationship between the input and the output, as has been mentioned over here. So the main idea of supervised learning is to really learn what is the relationship between Y and X. And we have been given these input output pairs. So what can be the possible examples of this? So X, which is the input, can be the pressure level of a patient, glucose level of a patient, etc. And Y can be whether or not the patient has a probability of having a heart attack, or whether or not the patient can have a heart attack in the near future. Another example could be X could be an image and Y could be whose face is it. So essentially, it is called as supervised learning because we are given question and answer pairs. We are given a set of data for which we know the question, which is X, and we know the answer, which is Y. For example, if the question is blood pressure, glucose levels, which is the input, the answer is which patient can have a heart attack. And the real challenge is, based on this data, we have to figure out how to answer future questions. So let's say the data set is like 50 patients, and whether they have a heart attack or not. So for 25 patients, the answer is yes. For 25 patients, the answer is no. The real question which we are planning to answer is that, let's say a new patient comes to me and I measure their blood pressure, glucose levels, etc. Can I predict whether this patient will have a heart attack or not? That is the main task of machine learning in this supervised setting. While I was exploring different examples of supervised learning, I understood that I generally got an idea of this, but I needed a practical demonstration. And that's when I encountered a website which is called as Teachable Machine. I'll attach the link of this website in the information of this video. It's a brilliant website to explore several different projects. And upon experimenting with this, I designed or developed a project which is a great example of supervised learning. So let me click on this image project. The goal of this project will be very simple. I'll give the machine or the computer 10 images of cats and 10 images of dogs, which are my input output pairs. So again, look at this particular case. The input will be the image and the output will be the whether it's a cat or whether it's a dog. This is the data set which is given to the computer. So let me actually upload this data. So here let me upload 10 images of cats which I have sourced from the internet. Here you can see that I have uploaded 10 cat image samples, and here let me upload 10 images of dogs. So here you can see that I have uploaded images of dogs here. These are my input output pairs. I have already told the computer that for these x's, which is the input, the output is a cat, and for these x's, which is the input image, the output is a dog. By x's I mean x, which is the input. So if you look at the input output pair, the x here is the image and the y is whether it's a cat or whether it's a dog. That's what I'm doing here right now. And the task of this machine learning model is to figure out from whatever I've given, that whenever I upload any new image, this AI model has to figure out whether it's a cat or whether it's a dog. Um, okay, so let me first train the model here. Currently, I'm not too concerned about whether what's happening behind this training, etc. I just want to showcase supervised learning. So I have told the computer these are cats, these are dogs. Now let's check on a new data. So the input I'll attach as file, and now the machine learning model is trained. And now let me check whether the computer or the machine is able to correctly classify any new image as a cat or a dog. Currently, when nothing is uploaded, you can see that with almost 50-50 probability, it says cat and dog. Now let me upload a test image of cat initially. And here you can see that with 100% accuracy, the AI model or the trained ML model is being able to recognize it as a cat. Isn't this amazing? I did not give this image before in the input data. This is a completely new image. Somehow the model has become intelligent to predict any new image as a cat or a dog. Now let me try to upload an image of a dog actually. Okay, now I have uploaded the image of a dog. Here you can see that with 100% accuracy, the ML, the trained ML model has classified this image as that of a dog. Somehow some magic is happening here, and the AI model or the ML model is detecting patterns, and now it is trained. Now it is trained to identify any image as a cat or a dog. Let me upload a difficult image actually. Let me upload side view here. Here you can see that even if I upload a side view, it still detects that it's a dog. Okay, let me try to upload another image. Still with 100% accuracy, now it's detecting that it's a cat. Probably it detected features. Probably it saw that cats have pointed ears, longer whiskers, and oval eyes. whereas dogs have flappy ears, round eyes, and we will never know what the AI identified here. We will come to that in subsequent videos, but right now, uh, this is when I truly understood why it is called as supervised learning. It is called supervised because it's like training a kid. We have given some images of cats and we have given some images of dogs, and we are training the machine that, okay, look, this is the training data, take this and learn from it whatever you want. But your task is, whenever I upload a new image, you should be able to classify it as a cat or a dog. The main essence of supervised learning is there are these input output pairs. So these input output pairs are based on or the computer or the AI is trained on these input output pairs. These are also called as labeled data. So we are labeling the data as cats and dogs, and we are supervising the training of the computer. So there is a correct answer and there is a wrong answer, and that's why it is called as the supervised learning. Okay. Then, when I explored supervised learning from the MIT's course further, I recognized that there is one more class of supervised learning which is called as classification. Then I became curious that what is classification? Essentially, classification is a kind of supervised learning problem where the output can take only discrete values like plus 1 or minus 1, cat or a dog. So here you see, this was an example of a classification problem because the output is either a cat or a dog. Similarly, the heart attack example which we discussed before is an example of classification problem, whether the patient will have a heart attack or no, plus 1, minus 1. Further, if there are only two output categories, then it is called as binary classification. So this is an example of a binary image classification problem. I became curious about classification further, and then as I explored the MIT's course, I wanted to look for practical examples of what can be a real life example of a classification problem. That's when I stumbled upon this particular website, in which this shows an entire AI project cycle of classifying brain tumor MRI images. I'll share this link also in the chat or in the information below this video. The main objective of this particular project is that, let's say you are a doctor in the healthcare space and you have received a image, an MRI scan of a patient. Can you train an ML model or an AI model to look at that image and tell whether brain tumor is present or absent? This is again binary classification because there are only two output categories possible, brain tumor present or absent. This is again an example of supervised learning because we have input output pairs. Let us look at these input output pairs. So if I click on start learning here, I will see that the data set consists of input output pairs of malignant and benign images. So let me actually look at this data set. Okay, so let me see five. So if I click on 5 here, I will see five malignant images, and if I click on benign, I will see five benign images. In this particular project, I noticed that they have trained around 120 in the training set, which means that there were 120 input output pairs given to the machine to train itself on. So the benign images looked something like this, and the malignant images looked something like this. If you look at these images closely, you will see that the malignant images have some kind of a spot here. Now, the real goal of this AI model is that based on the training data, it has to evaluate any new image as whether brain tumor is present or absent. So I came to the modeling section. I just clicked on train here, and I saw that the AI model is trained. Then I move to evaluation. This is what I want to show you guys right now. This is an example of binary image classification because if I take this image and if I test my model, now the AI model is trained, and it has made a mistake in this prediction. Now let me check the second. test your AI model. This is correct. So our model predicted benign and the actual value is also benign. So you see why this is an example of binary image classification, because the output can either be benign or malignant, plus one or minus one. Again, this is also an example of supervised learning because we are giving the computer input output pairs. We are giving the computer or the AI model rather these 120 images of malignant and 120 images of benign, and we are asking it to train so that whenever a new image is uploaded, it can correctly classify as whether the image is malignant or benign. This particular example really helped me to clear my understanding of binary image classification and also to clear my understanding of supervised learning. So this was all about supervised learning, and I was really excited because I felt I really understood what supervised learning is based on the teachable machine example and based on the a brain tumor example which we saw over here. Then I came to the next section, the next type of AI model. So the second type of AI model is called as unsupervised learning. And this really caught my attention because I was thinking, okay, I understood supervised. You give input output pairs, you train the system, and then you ask it to make prediction on a new data. But what is unsupervised learning? I learned that unsupervised learning does not involve learning a function from inputs to outputs based on a set of input output pairs. Instead, we are just given a data set and are expected to find some pattern or structure in it. This seemed like impossible to me. Whether just by giving a data set, how can we find pattern or structure in it if we are not training the computer on input output pairs? And I was very curious of what can be an example of unsupervised learning. Upon seeing several resources on the internet, I came across a beautiful example which illustrates unsupervised learning. It's this Amazon. So I went to Amazon and I searched tablet. I further went to this Apple iPad. No, I went to microphone. I typed microphone, and I went to the examples of mics. Now, when I went to the microphone example, I saw that it Amazon showed the price of this device. But what was actually very interesting was there was an additional section here which was titled "Customers who bought this item also bought." And I became really curious, how does Amazon provide this suggestion to me? Because I know that it provides different suggestions to different people. Upon investigating further, I realized what is happening is that based on what I have ordered in the past, based on my past order history, Amazon knows me as a customer, and then it finds other customers which are similar to me. So, using its machine learning algorithm, it learns my preferences and then it finds other customers who have similar preferences. So, let's say I like ordering electronics such as headphones, tablets, etc., and Amazon finds 100 other users who also like to order these type of things using its ML algorithms, and then it checks what these other customers bought. So if these other customers have bought this mic, it also recommends to me that I should also buy this mic. Did you see any input output pairs here? We are not telling Amazon to do anything. There is no correct answer or wrong answer here. What Amazon is doing is that it just has data, right? It just has data about what I am purchasing and what all other customers are purchasing. Just based on this data, it is finding patterns on its own. It is finding that okay, there are 150 users who like electronics like these, including me, and to these users I am going to recommend what to buy. So this was a beautiful example of unsupervised learning because it clearly follows this definition. Uh, there are no input output pairs here. Instead, we are just given a data set and we are expected to find a pattern or a structure in this data set. That's exactly what Amazon is doing here. There is no input output pairs, there is no correct or wrong answer. It just collects a huge amount of data and then it learns on its own to find some patterns in this data. And that's why it's called unsupervised, because we are not supervising Amazon by telling that, okay, this is the correct answer, this is the wrong answer. Here we are supervising the ML system. We tell that these are cats and this is the correct, you should not classify this as dog, that will be a wrong answer. That's why this is supervised, whereas this is unsupervised. I found one more very good example of unsupervised learning. This seems to be like a very famous AI problem upon researching further. It is called as the K-means clustering of the iris dataset. You should not focus on these two words right now, but just focus on this iris dataset. Basically, imagine that you are a botanical scientist who has visited a garden. Okay, you have visited a garden and there are huge number of flowers over there. I'll tell you the true answer. The true answer is that there are only three types of flowers in this garden: Iris setosa, Iris versicolor, and Iris virginica. But the main question is that you don't know that there are only three types. You have just seen this huge amount of flowers, and being a scientist, what you do is that you collect data. Being a scientist, you collect data of the sepal length, the sepal width, the petal length, and the petal width for all these flowers. To give you an understanding, this is what a petal looks like, and this is what a sepal looks like. So what you do is you visit all the flowers in the garden, and you collect measurements of the sepal length, the sepal width, the petal length, and the petal width. Then you ask yourself the question, okay, based on all these measurements, how many categories do these flowers fall into? Are all of these in two categories, four categories, six categories? You do not have information about this species right now, remember. So this is a great example of unsupervised learning because there is no correct answer. There is no answer on how many clusters will form, how many categories will form. All you have is this data. Remember, the definition of unsupervised learning is that we are just given a data set and are expected to find some pattern or structure in it. So what you do is that, okay, you are given this data and then you train a machine learning algorithm, which is called as k-means clustering. It's an unsupervised ML algorithm, and then you come up with this answer. You come up with the fact that just based on the data, this data clusters into three groups: the purple group, the yellow group, and the green group. That's amazing, right? Because that's actually what I told you earlier. There are three types of flowers. So just based on the data of the sepal length, the sepal width, the petal length, and the petal width, you are able to cluster all the flowers into three categories. So whenever you are given a new flower, you will just measure its sepal length, sepal width. You will find where which species it belongs to, and then you will classify that new flower as this particular species. This is the true power of unsupervised machine learning. Without telling the machine anything about the right answer and wrong answer, all you need to do is just give the machine a bunch of data and ask it to come up with things on its own. So here the ML algorithm discovers automatically that all of these flowers are bucketed into three types based on their measurements. And here, based on my preferences, the Amazon's AI figured out that I might like these items because other users who are similar to me also bought these items. In both these examples, the common thing is that they don't learn a function from input to output. Instead, they are just given a data set and they find some patterns or structure within the data set. After going through these examples, unsupervised learning made a lot of sense to me. And then I started looking at everything around me to see what is supervised, what is unsupervised. For example, I looked at the iPhone face unlock, and then I realized that when I bought the phone, I gave my face scan from different angles. So that is supervised learning. because there are input output pairs. Similarly, I started looking at every single thing around me, like self-driving cars. Self-driving cars are probably an example of supervised learning, because we are telling the car when it sees an image that okay, this is a pedestrian or this is another car. So then these definitions really broadened my perspective, and now I'm still thinking when I see systems around me whether they come under the category of supervised learning or unsupervised learning. I slowly discovered through this MIT course that there is a third type of ML models which not many people learn about in their basic introduction, and that is called as reinforcement learning. This looked a bit complicated to me, but upon investigating further, it's actually pretty exciting. So, in reinforcement learning, the goal is to learn a mapping from input values x to output values y, but without a direct supervision signal to specify which output values are best for a particular input. So the goal is to learn a mapping from x to y, but without a direct supervision signal to specify which output values are best for a particular input. I did not really understand what this meant, so I continued reading. So essentially, there is no training set, like there was a training set over here. There is no training set in reinforcement learning. The learning problem is framed as an agent interacting with an environment. This immediately caught my attention. Okay, what does it mean, agent interacting with an environment? Then I read further, and it said that agent interacting with an environment means this: the agent observes the current state, it selects an action, it receives a reward, and then agent goes to the new state. And then essentially the agent keeps on learning and keeps on updating its action. The goal is to find the mapping from x to y which maximizes the reward. Then slowly I started understanding what does it mean by no training set. Essentially, the whole scenario in reinforcement learning is completely different. Imagine when you are born in the world. Let's say you are an agent. You are interacting with the environment. Let's say you select an action and you receive a reward. Let's say you're an animal who is in a forest. You select an action of moving 5 steps forward and you find food there. That's amazing, right? Then you go to the new state and then you again start taking 5 steps forward because you think you might find a reward. So basically, your action either gives you a reward or does not give you a reward, and then you slowly learn from it. If, as an animal, you encounter that a particular area has predators, then that's a negative reward, right? So you won't ever go there again. So an agent is in an environment and the agent is learning. The goal is to find the actions of the agent, which is the goal is to find the mapping from x to y, which maximizes the reward. This seemed extremely interesting to me, but I wanted to see hands on examples. That's when I learned about AlphaGo. So it turns out that AlphaGo is a game which essentially, or Go is a game which essentially looks like this. And AI has now become smart enough to beat humans at this game. And this is apparently the best example of reinforcement learning. So then I started to understand what does this game actually mean. So it seems like it's a Chinese deterministic strategy game similar to chess. And then I saw that, oh wow, this looks pretty cool. I was going to read the rules. So to play Go, we need a grid of black lines, usually 19 by 19, and some white and black playing pieces called stones. Each player aims to surround more territory than the opponent using the stones. The players alternatively put a playing piece in an empty intersection of the board, and after that, they cannot move it. The only situation in which they can take the stone is if it is surrounded by opponent ones, and in this case, the stone is captured. I vaguely understood this, and I understood that this is a strategy game where players have to outcompete the other. And I learned that if you want to train an AI system to beat humans at this game, it is a problem of reinforcement learning. Imagine that the AI system is like an agent and it makes some move. Let's say the agent observes the current state and it selects an action. Let's say the agent moves some piece. and that turns out to be a very bad move because the opponent is winning. Then the agent learns on its own. If the agent makes a good move, then it receives a reward because it wins that match. So then that's essentially reward for that agent. And then the agent essentially modifies and learns its new strategy. It turns out that when you train an AI on millions of games, the agent becomes so good that if it is placed in any new environment with a new opponent, probably the best Go person in the world, it has trained on millions of games so that it's intelligent enough to know exactly how the new environment behaves. This is called reinforcement learning because we reinforce things. If the agent receives a reward, that particular move is reinforced, which means that the AI should keep on making that move again because that might lead to victory. If the AI selects a wrong action, then it does not receive a reward, it loses. Then we reinforce to the AI that you should never take a move in this particular situation like this. So the agent learns. So these are examples of reinforcement learning. Another example is of course chess. And when AI actually now AI beats even chess grandmasters, that is because again it has been trained in millions of games, millions of situations through reinforcement learning, where there is no real training set here. It's not even unsupervised learning because there are input values and there are output values, right? In the chess game, the input values are where you move the pieces, the output values are whether you get or whether you have victory or not, or how many moves it takes for you to be victorious. So there are input output pairs. So it's not even an example of unsupervised learning. That's why there is a new category for it, which is called as reinforcement learning, where the agent observes the current state, selects an action, receives reward, or does not receive a reward, and then the agent goes to the new state and it keeps on learning. So, whenever you see gamified environments and whenever you see AI mastering games which have patterns such as chess or Go, that is typically an example of reinforcement learning. So, this was all which I learned in day three. I essentially really had a very clear understanding on now of the three types of ML algorithms. The main thing I kept in mind was that supervised learning has input output pairs, and the goal is to learn the relationship between input and output. And then, using that relationship, we have to figure out how to answer future questions. The best example I will keep in mind to think of supervised learning is this cats and dog image classification example. Then I went to binary classification. So essentially, I discovered that classification is a subcategory of supervised learning, and binary classification has two outputs, either plus one or minus one. I saw an example of the brain tumor here, where the input category was the images, and the output was whether it's malignant or benign. That's why it was binary classification. I also looked at the power of AI in healthcare applications. If you have millions of such images, instead of manually classifying them, if AI is trained, it can do these binary classification tasks on its own. Then I learnt about the second category of ML models, which is unsupervised learning. I discovered that in unsupervised learning, there is no real function between inputs and outputs, and there is no correct answer also. Instead, we are just given a data set and are expected to find some pattern or structure within it. I looked at this Amazon example where customers who bought this item also bought, and I looked at the iris clustering example, and I noticed similarities between these two. I noticed that there is no input output pairs in both. We are just given data, and then Amazon in this case and the ML model in this case are making predictions just based on the data. In that sense, unsupervised learning is really very cool because we are not telling the AI what to do, it figures it out on its own. The third category I saw, which neither comes under supervised or unsupervised learning, is reinforcement learning. The reason it does not come under supervised learning is because there is no training set. The reason it does not come under unsupervised learning is because there are input output values. uh, okay, what is reinforcement learning? I saw that in reinforcement learning the environment itself is different. We think of agents in an environment where the agents are at their current state, they select an action and they receive reward or punishment. Based on this, they keep on learning and alter their state. If the agent is trained enough times in that environment, it learns to find the best strategy or policy which will maximize the reward. Two examples of this are the Go and AI playing chess. In Go, this is reinforcement learning, and as the agent learns when it gets rewards, which move leads to better rewards, after being trained on millions of games, it develops a policy where it will get the maximum reward in any game, and that's how it can beat any Go player in the world. Similarly, for chess, um, the agent learns which moves lead to rewards or victorious games, and then it updates its state and takes actions accordingly. After being trained on millions of games, it learns the best policy, which will lead to the maximum reward in any future game. That's why AI actually beat chess grandmaster Gary Kasparov in 1996. And I did not know the technology behind this, but I now know that it is because of reinforcement learning. So this brings us to the end of day 3, in which we learned about the three types of ML. In the next video, we will learn about the 7 steps to run any ML algorithm or to deploy any ML project in real life. Thank you, and I will see you in the next lecture. Please follow with me as these lectures are proceeding. The main goal behind which I'm making this series is so that you get inspired when you see someone else learning with you. And I'll be uploading something almost every day. So I hope you are enjoying this and finding value out of these videos. Thank you so much.